These are the notes for Learning Target 3.2, Quantitative Force Models, in which we're going to select and use the correct quantitative model for forces due to gravity, springs, and friction. So on our equation sheet, these are the three equations that we're going to be talking about today. The first one is about gravitational force, and so on your note packet you can write down gravitational force as the title above this information. Gravitational force is also called weight. So if we ask for the weight of something, we're looking for the gravitational force measured in newtons of an object. And to find that gravitational force, we multiply the mass of the object measured in kilograms by the acceleration due to gravity, or the gravitational field strength of 9.8. The second quantitative force model we're going to use is spring force. Spring force is the amount of force that is provided by a spring that's either stretched or compressed. And so to calculate the spring force, we need to multiply the K, or spring constant, which is a measure of how stretchy the spring is. So a high K value, or high spring constant, is a very stiff spring. A small spring constant is a very stretchy spring, multiplied times the displacement, which is how much the spring is compressed or extended. And that should be measured in meters. And our last quantitative model is for friction force. In order to calculate the friction force provided between two surfaces, we need to know the coefficient of friction, which the coefficient of friction is a unitless number. And what it is it's a property of the material, or really a property of two materials, and how they interact with each other. So different materials will have different coefficients of frictions. Things that are very slippery have low coefficients of friction, and then things that are rough or not easy to slide past each other will have a high coefficient of friction. The highest coefficient of friction that we can have is 1. And then what we multiply that by is the normal force provided by the surface that some object is interacting with. And we'll see an example of that later. So for the first example, we have a question that says, what is the spring force in a spring with a spring constant of 180 newtons per meter when it stretches 0.05 meters? And so the things that we know are the spring constant and the displacement. What we don't know is the spring force. And so then the equation we're going to use that has these three variables in it is the second one that we looked at. We can plug in the spring constant and the displacement, and if we multiply them, we get that the spring force in this spring is, or the spring force provided by the spring rather, is 9 newtons. For our second example, an object experiences 20 newtons of gravitational force on Earth. What is the mass of the object? And so the first given is that the gravitational force is 20 newtons. And also, since we're on Earth, we know that the gravitational field strength is 9.8 meters per second squared. And what we want to know is the mass. So the only equation that has these three variables in it is this one. We can substitute the force of gravity and the gravitational field strength. And then if we divide both sides by 9.8, we get that the mass is 2.04 kilograms. And the third example says a block is pushed across a table. If the table provides 8 newtons of normal force and the block experiences 1.5 newtons of friction force, what is the coefficient of friction between the block and the table? So here we have a block being pushed along a table. The force diagram for that would look like this. So we've got force of gravity pulling the block down, and then the table is pushing the block back up. Then whatever object is pushing it, here I said hand, but something is pushing the block to the right with a normal force, and friction is counteracting that motion. So we're really focused on the normal force by the table and the friction force by the table. And you can see how both of these forces in their subscripts have the same object that they're on, which is the block, and the same object that they're by, which is the table. That will help us avoid choosing the wrong normal force if there is more than one in a problem. So our knowns is that the normal force from the table is 8, and the friction force from the table is 1.5 newtons. We don't know the coefficient of friction, and so we'll use this equation. We can substitute the values into it, and we can divide both sides by 8 to get that the coefficient of friction is 0.19. Thank you for watching.